Good morning everyone. So today in this video we are going to discuss about principles of operation of IC engine. In this we will be seeing the working of 2-stroke and 4-stroke diesel and petrol engine. First let's see about the 4-stroke diesel engine. In 4-stroke cycle engine, there are 4 strokes completing 2 revolutions of the crankshaft. These are respectively the suction, compression, power and exhaust stroke. In figure, the piston is shown descending on its suction stroke. Only pure air is drawn into the cylinder during this stroke through the inlet valve, whereas the exhaust valve is closed. This valve can be operated by the cam, push rod and rocker arm. The next stroke in the is the compression stroke, in which the piston move up with both the valves remaining closed. The air which has been drawn into the cylinder during the suction stroke is progressively compressed as the piston ascends. The compression ratio usually varies from 14:1 to 22:1. The pressure at the end of the compression stroke range from 30 to 45 kg per centimeter square. As the air is progressively compressed in the cylinder, its temperature increases until when near the end of the compression stroke, it becomes sufficiently high, that is to 650 to 800 degrees Celsius, to instantly ignite any fluid that is injected into the cylinder. When the piston is near the top of its compression stroke, a liquid hydrocarbon fuel such as diesel oil is sprayed into the combustion chamber under high pressure, that is nearly 140 to 160 kg per centimeter square, higher than that of existing in the cylinder itself. This fuel then ignites, being burned with the oxygen of highly compressed air. During the fuel injection period, the piston reaches the end of its compression stroke and commences to return on its third consequent stroke, that is power stroke. During the stroke, the hot product of combustion, consisting chiefly of carbon dioxide together with the nitrogen left from the compression air, expand, thus forcing the piston downward. This is only the working stroke of the cylinder. During the power stroke, the pressure falls from its maximum combustion value, that is 47 to 55 kg per centimeter square, which is usually higher than the greater value of compression pressure 45 to 45 kg per centimeter square, to about 3.5 to 5 kg per centimeter square near the end of the stroke. The exhaust valve then open, usually a little earlier than when the piston reaches its lowest point of travel. The exhaust gas is wiped out on the following upward stroke of the piston. The exhaust valve remains open throughout the whole stroke and closes at the top of the stroke. The reciprocating motion of the piston is converted into rotatory motion of the crankshaft by means of connecting rod and crankshaft. The crankshaft rotates in the main bearing, which are set in crankcase. The flywheel is fitted on the crankshaft in order to smoothen out the uneven torque that is generated in the reciprocating engine. Next, let's see about the 2-stroke cycle diesel engine. The cycle of the 4-stroke of the piston, that is the suction, compression, power and exhaust stroke, of four-stroke cycle engine is completed only in the two-stroke. In the case of two-stroke engine, the air is drawn into the crankcase due to the suction created by the upward stroke of the piston. On the downward stroke of the piston, it is compressed in the crankcase. The compression pressure is usually very low, being just sufficient to enable the air to flow into the cylinder through the transfer port. When the piston reaches nearer the bottom of its downstroke, the air thus flows into the cylinder where it is compressed by the piston at its ascents till the piston is nearly at the top of its stroke. The compression pressure is increased sufficiently high to reach the temperature of the air above the self-ignition point of the fuel used. The fuel is injected into the cylinder head just before the completion of the compression stroke and only for a short period. The burned gases expand during the next downward stroke of the piston. These gases escape into the exhaust pipe to the atmosphere through the piston, uncovering the exhaust port. Modern two-stroke cycle engine. The crankcase method of air compression is unsatisfactory as the exhaust gas do not escape the cylinder during port opening. Also, there is a toss of air through the exhaust port during the cylinder charging process. To overcome these disadvantages, blowers are used to pre-compress the air. This pre-compressed air enters the cylinder through the port. An exhaust valve is also provided which opens mechanically just before the opening of the inlet ports. In this gasoline is mixed with air. So next we will see about the four-stroke spark ignition engine, that is petrol engine. In this, gasoline is mixed with the air broken up into mist and partially vaporized in the carburetor. The mixture is then sucked into the cylinder. There it is compressed by the upward motion of the piston and ignited by the electric spark. So the compression pressure is nearly 5 to 10 kg per centimeter square. So after ignition, the expanding gas exerts a pressure on the piston. There is power stroke. So the ignition temperature is 1945 to 2200 degrees Celsius. So after the power stroke, the exhaust gas escape into the next upward movement of the piston. The stroke was similar to those discussed under four-stroke diesel engine. The compression ratio varies from 4:1 to 8:1 and the air fuel mixture from 10:1 to 20:1. Next we will see about the two-stroke spark ignition engine. The two-cycle carburetor type engine makes use of an airtight crankcase for partially compressing the air fuel mixture. As the piston travels down, the mixture previously drawn into the crankcase is partially compressed. As the piston nearer the bottom of the stroke, it covers the exhaust and intake port. The exhaust flow out, reducing the pressure in the cylinder. When the pressure in the combustion chamber is lower than the pressure in the crankcase through the port openings to the combustion chamber, the incoming mixture is deflected upward by an baffle on the piston. As the piston moves up, it compresses the mixture above and draws into the crankcase below a new air fuel mixture. The two-stroke cycle engine can be easily identified by the air fuel mixture valve attached to the crankcase and the exhaust port located at the bottom of the cylinder. So next we will see about the comparison of CA and SA engine. First, reliability of CA engine is much higher than that of the SA engine. The distribution of fuel to each cylinder is uniform as each of them have a separate injector, whereas in SA engine the distribution of fuel mixture is not uniform owing to the design of the single carburetor and the intake manifold. Since the servicing period of the fuel injection system of CA engine is longer, its maintenance cost is less than that of the SA engine. The expansion ratio of CA engine is higher than that of the SA engine. Therefore, the heat loss of the cylinder valve is less in CA engine than that of the SA engine. Consequently, the cooling system of the CA engine can be of smaller dimensions. The torque characteristics of the CA engine are more uniform, which result in better top gear performance. The CA engine can be switched over from part load to full load soon after starting from cold, whereas the SA engine requires warming up. The fuel for the CA engine is cheaper than that of the SA engine. The fire risk in CA engine is minimized due to the absence of ignition system. Due part load, the specific fuel consumption of CA engine is low. Next we will see about the advantages of two-stroke cycle over four-stroke cycle engines. The two-stroke cycle engines gives an working stroke for each revolution of the crankshaft. Hence, theoretically, the power developed for the same engine speed and the cylinder volume is twice that of the four-stroke cylinder engine, which gives only one working stroke for every 2 revolutions of the crankshaft. However, in practice, because of the poor scavenging, only 50 to 60% extra power is developed. Due to one working stroke for each revolution of the crankshaft, the turning moment of the crankshaft is more uniform. Therefore, a two-stroke engine requires a lighter flywheel. The two-stroke engine is similar in construction. The design of its parts is much simpler and their maintenance easy than that of the valve mechanism. The power required overcoming frictional resistance of the suction and exhaust stroke is saved, resulting in some economy of fuel. Owing to the absence of camshaft, rocker, etc. of the valve mechanism, the mechanical efficiency is higher. The two-stroke engine gives less oscillation. For the same power, a two-stroke engine is more compact and requires less space than a four-stroke cycle engine. This makes it more suitable for use in small machines and motorcycles. A two-stroke engine is lighter in weight for the same power and speed, especially when the crankcase compression is used. Due to its simpler design, it requires fewer spare parts. A two-stroke cycle engine can be easily reversed if it is of the valueless type. Disadvantages of two-stroke cycle over four-stroke cycle engine. The scavenging being not very efficient in the two-stroke engine, the dilution of the charges takes place, which result in poor thermal efficiency. The two-stroke spark ignition engine does not have an separate lubrication system, and normally lubricating oil is mixed with the fuel. This is not as effective as the lubrication of a four-stroke engine. Therefore, the part of two-stroke engine are subjected to greater wear and tear. In a spark ignition two-stroke engine, some of the fuel passes directly to the exhaust. Hence, the fuel consumption per horsepower is comparatively high. With heavy load, a two-stroke engine gets heated up due to the excessive heat produced. At the same time, the running of the engine is not very smooth at light loads. It consumes more lubricating oil because of the greater amount of heat generated. So next we will see about the firing order. The sequence in which the power stroke cylinder occurs is called firing order. The arrangement of the crank pin on the crankshaft and the design of the camshaft both determine the firing order. What is firing interval? The interval between successive power stroke in different cylinder is called firing interval and is determined in four-stroke engine as follows. Firing interval is equal to 1 cycle or 2 revolution of crankshaft, that is 720 degree, divided by number of cylinders. For two-stroke engine, the formula for firing interval is 360 divided by number of cylinders. Balance and firing order of engine. For a single cylinder engine, there is one power stroke in 2 revolution of the flywheel. The movement of the flywheel therefore cannot be smooth and quiet. To compensate for this unevenness in the revolution of the flywheel, it is normally made heavy and large. For a four-cylinder engine, the power impulse are available twice in every revolution of the flywheel. That is, every time there is a power stroke in one of the cylinders. As a result, the movement of the flywheel is smooth and free from noise. From the above description, it is apparent that the larger the number of cylinders, smoother the rotation and lesser the vibration and problems of balancing. The flywheel has to store and release less energy, therefore it can be lighter than those used in the engines with fewer cylinders. Single cylinder engine. The reciprocating parts such as the piston and the connecting rod are one each in single cylinder engine, and there is no provision to counterbalance their weight. Therefore, the mechanical balance in single cylinder engine is poor. However, by providing counterweight to the crankshaft and heavy flywheel, single cylinder engine can be balanced to some extent. However, fluctuation in the speed of the engine will cause vibration even in the best designed single cylinder engine. Two-cylinder engine. The crankshaft pin in this case are 180 degree apart, and thus when one piston is going down, the other goes up. Three-cylinder engine. The firing interval in this case is 720 divided by 3. So it is 240 degree. The crankshaft has been designed with crank pin 120 degree apart. Four-wheel cylinder engine. Firing interval here is 720 divided by 4, that is 180 degree, and the crankshaft is designed with crank pin 1 and 4 in one direction and 2 and 3 180 degree apart. As the position of 1 and 2 is always moving opposite to that of the 2 and 3, they tends to neutralize the effect of primary inertia forces. When the arrangement of cam, with the arrangement of cam, two types of firing order can be achieved. By the one most commonly used is 1 3 4 2. Hence the crank revolution is smoother. Next is 6-cylinder engines. The crankshaft is arranged such that the crank pin 1 and 6, 2 and 5 and 3 and 4 are in the same radial plane 120 degree apart. The firing interval is 720 degree divided by 6 is equal to 120 degree. That is, in 2 revolution of the crankshaft, 6 power stroke will be available with an firing interval of 120 degree. In other words, after each 120 degree, there will be a power overlap for 60 degree. The crankshaft can be arranged in either of two of the way, and the firing order will be 1 4 2 6 3 5 and 1 5 3 6 2 4 respectively. So this is the end of our video. Thank you.